Introduction to the z-test. The z-test is a statistical method used to determine if there is a significant difference between the sample and population mean. It is applicable when the population variant is known or the sample size is large. Understanding the z-test is crucial for hypothesis testing in a various field, including psychology, medicine, and business. When to use a z-test? A z-test is appropriate when the sample size exceeds 30, ensuring a normal distribution of the sample mean. It is used when the population standard deviation is known, allowing for accurate calculation. The z-test can be applied in scenarios like comparing sample mean to a known population mean. Types of a z-test. There are three main types of a z-test: one sample, two sample, and z-test for proportion. A one sample z-test compares the sample mean to a known population mean. The two sample z-test compare the mean of two independent samples to see if they differ significantly. Hypothesis formation. The first step in conducting a z-test is to formulate the null and alternative hypothesis. The null hypothesis typically states that there is no effect or difference. The alternative hypothesis posits that there is a significant difference. Significance level. The significance level, or alpha, is the threshold for rejecting the null hypothesis. Common alpha level are 0.05 or 0.1 and 0.10, indicating the probability of making a type error. Choosing an appropriate significance level is crucial for the reliability of the test result.
Calculating the z-score. The z-score is calculated using the formula z equals xu on. Here, x is the sample mean, u is the population mean, o is the population standard deviation, and n is the sample size. The z-score indicates how many standard deviation an element is from the mean. Z-score formula: row score, x, u, mean, o for standard deviation. Interpreting the z-score. A calculated z-score can be compared to a critical value from the z-table. The critical values for a 90% confidence interval are 1,645 and minus 1,645. If the z-score falls beyond the critical value, the null hypothesis can be rejected. The direction of the z-score also indicates whether the sample mean is higher or lower than the population mean. Z-test proportions. A z-test for proportions compare the observed proportion in a sample to a non-population proportion. The formula used is z equals pp squared p1 n, where p is the sample proportion and p is the population proportion. This test is useful in fields such as marketing and epidemiology. Assumption of the z-test. The z-test assumes that the data follows a normal distribution, especially with the smaller sample sizes. It also assumes that the samples are independent of each other. The z-test requires that the population standard deviation is known, which may not always be the case. Example scenario: one sample z-test. Suppose a research wants to test if the average height of a sample of students is different from the known average height of 170 cm. The researcher collects data from 50 students, calculating the sample mean and standard deviation. The z-test is then applied to assess whether to reject the null hypothesis that the average height is 100 cm. Interpret the result. Example: perfume bottle producing 50 cc with SD of 2 cc. 100 bottles are randomly picked and the average volume was found to be 150.2 cc. Has mean volume change? 95% confident. Example scenario: two sample z-tests. Two different teaching methods are compared to assess their impact on student performance. Sample A consists of student taught with method 1, and sample B consists of students taught with method 2. The z-test is conducted to determine if there is a significant difference in the average scores of both groups.
Conclusion of z-test principles. The z-test is a fundamental tool for hypothesis testing in statistics. It provides a clear method for assessing the significance of differences between means. Mastery of the z-test is essential for effective data analysis in research and discussion making. Number 1. Formulate a hypothesis. Number 2. Collect data. Number 3. Analyze data is to test hypothesis. Number 4. Draw conclusion. Practical application of z-tests. Z-tests are widely used in clinical trials to evaluate the effectiveness of new drugs. Business tests utilize z-tests for quality control to ensure products meet specifications. Social scientists apply z-tests to analyze survey data and draw conclusions about populations. Tools for performing z-tests. Statistical software such as SPSS, R, and Python can perform z-tests with ease. Online calculators are available for quick z-test computations. Mastery of spreadsheet function in Excel can also facilitate z-test calculations. Frequently asked questions. What is the main difference between z-test and t-test? The z-test is used when the population variant is known, while the t-test is used when it is unknown. How do I choose between a one sample and a two sample z-test? Summary of key points. The z-test is essential for hypothesis testing a statistic and has specific application. Understanding its assumptions, calculation, and interpretation is crucial for accurate results. Practitioners should be aware of its limitation and when to apply alternative tests.